Sir, voice is not audible. Hello? Sir, voice is not audible.
It is my voice is audible.
Yes, sir.
Okay.
Yes, sir.
Okay. If we see there, these are the two gears, gear one and gear two. D1 is the diameter of the gear one, and D2 is the diameter of the gear two. Here we see the spiral gear is left-handed, and spiral two gear is also left-handed. We have to discuss here the what is the shaft angle. If we see here, the theta is the shaft angle. Theta is the shaft angle, and alpha 1 alpha 1 is the spiral angle for a gear 1, and alpha 2 is the spiral angle of the gear 2. Okay, alpha 1 is the spiral angle for a gear 1, and alpha 2 is the spiral angle for a gear 2, and theta is the shaft angle with theta, and it is summation of alpha 1 plus alpha 2. Means if the two gears are same handed in a spiral, if in a spiral gear, if the gear 1 is left handed and gear 2 is also left handed, then shaft angle theta is a summation of spiral angle 1 plus spiral angle 2. Okay, and in this case, the spiral gear 1 is a right handed and spiral gear 2 is a left handed. Okay, gear 1 is right handed, gear 2 is left handed. Then shaft angle theta is equal to alpha 1 minus alpha 2. Here alpha 1 is the spiral angle of the gear 1 and alpha 2 is the spiral angle of the gear 2, and if we take the difference of these two, then we will get the shaft angle. Then what is mean by shaft angle? Shaft angle is the angle through which any one shaft, there are two shafts, suppose we consider shaft 1 and shaft 2, and these two shafts are non-parallel, non-intersecting with each other. And if I rotate the shaft 1 through angle theta so that it is parallel to second shaft, means if I rotate one shaft in some angle, I want to rotate the shaft 1 through with how much degree? Theta degree, so it is parallel to the second shaft. Means जर मी मला शाफ्ट 1 हा इतक्या अँगल मध्ये रोटेट करायचा की ज्यामुळे शाफ्ट 2 ला तो पॅरलल होईल, अशा प्रकारे रोटेट केला तर तो जो काही अँगल आहे त्याला शाफ्ट अँगल म्हणतात आणि तो डिनोट केला जातो थीटाने. सिमिलरली in case of in if we consider this is a case 1, this is case 2, only remember that if the same handed gears are used, then theta is alpha 1 plus alpha 2, and if the opposite handed gears are used, then theta is equal to shaft alpha 1 minus alpha 2. Okay, this is the shaft angle, and how this shaft angle is calculated for different hands of the gears. Now, shaft angle theta is the angle through which one of the shaft must be rotated so it is parallel to the other shaft. जर एक शाफ्ट मी रोटेट केला तर अशा प्रकारे रोटेट करायचं की दुसऱ्या शाफ्टला पॅरलल असेल, आणि ज्या अँगलने तो रोटेट केलेला असेल तर तो जो काही अँगल आहे त्याला म्हणतात शाफ्ट अँगल. If the hands of the meshing spiral gear are same, if the hands of the meshing spiral gear are same, then shaft angle theta is given by alpha 1 plus alpha 2. And if the hands of the meshing spiral gear are different, then shaft angle theta is equal to alpha 1 minus alpha 2. Okay, these are the some important logic, or how can we calculate the shaft angle. Now center distance between a spiral gear. How can we calculate the center distance between a two spiral gear? Let L is the center distance between a spiral gear. Alpha 1 and alpha 2 is the spiral angle for a gear 1 and gear 2 respectively. T1, T2 are the number of teeth. Generally remember that T or Z. In some books there are the notation is T or Z is used for a number of teeth. Generally Z is used, but in some books T also used. The T1 and T2 is the number of teeth on a gear 1 and 2. N1 and N2 is the speed of the gear 1 and 2. Gear ratio. Gear ratio is denoted by the G and it is equal to T2 by T1 or N1 by N2. MT1 and MT2 is the transverse module for a gear 1 and 2. NM is the normal module for a gear 1 and 2. Here the normal module is same for both the gears. Therefore, the normal module Mn is this for gear 1 and 2. R1, R2 is the pitch circle radius for a gear 1 and 2. R1 and R2 are the pitch circle radius for a gear 1 and 2. We know that the pitch circle radius is for a gear is formula. We know that is the pitch circle radius. R is equal to MT means transverse module into number of teeth divided by 2. Radius is equal to transverse module into T divided by 2. The pitch circle radius for a gear 1. Pitch circle radius for a gear 1 R1 is equal to MT1 into T1 divided by 2. Pitch circle radius for a gear 2 is equal to MT2 into T2 by 2. Okay. Then the center distance between the two spiral gear is R1 plus R2. If I take the summation of radius of the gear 1 and radius of the gear 2, we will get the center distance. So L is equal to MT1 into T1 by 2 plus MT2 into T2 by 2. And transverse module, if I want to convert the transverse module into normal module, then transverse module is equal to normal module divided by cos of alpha 1. We put here instead of the MT1 we put Mn into cos of alpha 1 and MT2 is equal to Mn into cos of alpha 2. Here we will take Mn by 2 as a common and here we get T1 by cos of alpha 1 plus T2 by cos of alpha 2. Okay, then here I will take the T1 as a common. Therefore, here 1 by cos of alpha 1 and I take the T1 as a common. Therefore, we will get here T2 by T1. Here we will get T2 by T1. Therefore, L is equal to Mn into T1 by 2 into 1 upon cos of alpha 1 plus G upon cos of alpha 2, where G is equal to T2 by T1. And this is a formula which is used to calculate the number of teeth, sorry, the center distance between the two spiral gear in terms of number of teeth and the gear ratio. By using this formula, we can calculate the number of teeth, sorry, the center distance between the two gears. Okay. Now next term is efficiency of the spiral gear. First of all, what is mean by efficiency? Efficiency means output upon input. How much output I obtain when I give some input. Suppose I'm giving an input as 100 kilowatt power and at the output I will get 90 kilowatt the power. Then efficiency of this system is 90%. Now here I want to calculate the efficiency of the spiral gear. So how can we calculate the efficiency? Remember, this derivation will not ask in a theory examination. Only remember the final. I will take this derivation whole, but for final examination this question is generally not asked, so concentrate on only formula, not on its derivation. But I will take the whole derivation here. The efficiency of the spiral gear, the efficiency is equal to output upon input. Here I consider the gear 1 as a driver, means I am giving the input to the gear 1 and giving the output to the, and I obtain the output at the gear 2. Okay, remember that I will first of all I will explain the terminology which is used here, and then we will move further. The terminology used here is FT1, tangential force acting on a gear 1. FT2 is the tangential force acting on a gear 2. What is FT1? Tangential force, and tangential force are used full component of the overall force, and which is used to transmitting the power or a motion from gear 1 to 2, and axial force are responsible for separating the two gears, and tangential force are responsible for transmitting the motion. FA is the axial force. Here one is remain. FA1 is the axial force acting on a gear 1. FA2 is the axial force acting on a gear 2. FN is the normal reaction at a point of contact. What is FN? FN is the normal reaction which is acting at a point of contact. F is the resultant force or a resultant reaction at a point of contact. Alpha 1 is the spiral angle for a gear 1. Alpha 1 is the spiral angle of the gear 1. What is the spiral angle? Spiral angle is the angle at which the teeth of the spiral gear are inclined to the axis of the gear. It is similar to that of the helix, but in helical gear, the teeth are straight, and in spiral gear, the shape of the teeth are a spiral. Alpha 2 is the spiral angle for a gear 2. Alpha 2 is the spiral angle for a gear 2. Now next terminology is theta. Theta is the shaft angle. Theta is the shaft angle, and which is equal to alpha 1 plus alpha 2. If the two gears are same handed, then theta is equal to alpha 1 plus alpha 2. And if the two gears are different handed, then theta is equal to alpha 1 minus alpha 2. Phi is the angle of friction. Just like in a helical gear or a spur gear, we use the term phi is as a pressure angle. Here the term phi is used as a friction angle. N1 is the speed of the gear 1, N2 is the speed of the gear 2, G is the gear ratio, and it is equal to T2 by T1 or N1 by N2. Then MT1 is a transverse module for a gear 1, MT2 is the transverse module for a gear 2, and MN normal module for a gear 1 and 2. D1 and D2 are the, D1 is the pitch circle diameter for gear 1 and D2 is the pitch circle diameter for a gear 2. Then first of all I will copy this. See in this image, here I want to take a triangle PAB. For a triangle PAB, AP is equal to FT1. because tangential force acting at a tangent to the tangential direction to the gear. Here this straight rectangle represent the gear 1 and this inclined rectangle represent the gear 2. For the gear 1, Ft1 is the tangential force and it's acting at a tangent to the gear. Here Fa1 is the axial force which is responsible for separating the gears, and F is the resultant force. Here F is the resultant force. Alpha 1 is the helix angle for a gear 1, spiral angle for a gear 1. Similarly here Ft2 is the tangential force for a gear 2, Fa1 is the axial force for a gear 2, Fn is the normal reaction at a point of contact, and alpha 2 is the spiral angle for a gear 2. Now work efficiency is the output upon input. Input is given to the gear 1 because gear 1 is as a driver, therefore work input is equal to omega 1 into mt1. Here work input is equal to 2 pi n divided by 60 into mt1, and work input, here mt1 means, remember here
काय
mt1 represent the
ओके पेस्ट काय म्हणली कोणती आलं लसूण का हे टाकायचे अजून
mt1 is the torque which is acting on a gear 1. Therefore input power is equal to 2 pi n1 divided by 60 into mt1. mt1 is equal to tangential force into radius. For a gear 1 radius is r1 and tangential force is ft1. Therefore work input is equal to 2 pi n1 divided by 60 into ft1 into d1 by 2. We replace the radius in terms of diameter, therefore work, this 2 will get cancelled, therefore input power is equal to pi d1 into n1 divided by 60, and ft1, if we see in this triangle, if we see in this triangle, ft1, we write is ft1 in terms of overall force. In overall terms, therefore, if we write ft1 in terms of f, we will get ft1 is equal to f into cos of alpha minus phi. Alpha 1 is the spiral angle of the gear 1 and phi is the friction angle. Then similar, if we used the output, we will get output is equal to pi d2 into n2 into cos divided by 60 into f into cos of alpha 2 plus phi. If we take the output, because output is obtained at a gear 2 and output power is equal to pi into d2 into n2 divided by 60 into f into cos of alpha 2 plus phi. And therefore efficiency is equal to work output upon work input. If I put the value of output here and value of input here, we will cancel this pi will get cancelled, this 60 will get cancelled, f will get cancelled, and we will get the efficiency is equal to d2 into n2 into cos of alpha 2 plus phi divided by d1 up into n1 into cos of alpha 1 minus phi. And if we simplify this, mn, normal module is represented mt1 into cos of alpha 1, and mt1 transverse module is equal to diameter divided by number of teeth. Therefore we will get d1 is equal to mn into t1 divided by cos of alpha 1, and d2 is equal to mn into t2 into cos of alpha 2. And if we put this value in this equation, and if we simplify this equation, we will get efficiency is equal to cos of alpha 1 into cos of alpha 2 plus phi, cos of alpha 2 into cos of alpha 1 minus phi. And if we again simplify this, for maximum efficiency, if we want to maximum efficiency, then the cos of alpha 1 minus alpha 2 minus phi should be equal to, because maximum value of the cos of any term, the maximum value of cos of any angle is 1, and which is get at the 0. Therefore alpha 1 minus alpha 2 minus phi is equal to 0. Therefore alpha 1 minus alpha 2 is equal to phi, and alpha 1 is equal to alpha 2 plus phi. Or similarly alpha 2 is equal to alpha 1 minus phi. And if we simplify this, efficiency of the spiral gear maximum efficiency of the spiral gear is equal to cos of theta plus phi plus 1 cos of theta minus phi plus 1, and theta is equal to alpha 1 plus alpha 2. Therefore alpha 1 is equal to theta minus theta alpha 2. I will share this PPT with you. You go through it, and if you have any doubt regarding this, you can ask me, because this derivation will not ask for a final examination, only numerical will ask, and which is depend on only this formula. The numerical, if the numerical will ask on a spiral gear this to calculate the efficiency of the spiral gear, then this formula will used, because this derivation is little bit complicated and it is not asked for final examination. Always only remember that the efficiency will depend on only the friction angle and shaft angle. Okay, so this is a formula for maximum efficiency of the spiral gear. I will share this PPT on a Google Classroom, so you can go through it, and if you have any doubt, you can ask me. Okay. I will share the attendance link. Mark your attendance, and if you have any doubt regarding any terms, ask me anytime.